I am so excited to talk with the luminous Randall Munroe, creator of the incomparable webcomic and, let's be real, cultural phenomenon that is XKCD. Like many of my favorite people, Randy is a multi hyphenate human. He's an author and an engineer and a Hugo Award winner as well. And it's hard to overstate the cultural impact your work has had on society since you first started putting pen to paper, or perhaps pixels to screens is a little bit more apt, but I know you've done both. But ever since the Union of Concerned Scientists gave me a show, I've been slowly but surely cajoling the most interesting people I know into appearing on it. And I'm so glad that you are my next victim slash participant. So thanks so much for being here. And I wanted to start by referencing my personal gateway drug sample of XKCD, which was comic number 162, which I'm pretty sure I saw on LiveJournal way back in the day. And, you're now on comic number 2,993. So, at any rate, your comic on angular momentum is what first invited me into your world. And I wanted to ask, what made you decide to show your audience your blend of humanity and curiosity using wildly emotive stick figures?
I don't know. I mean, I think everyone wants to, reach out to other people and find people who are interested in the kinds of things they are. And a lot of the time when I started drawing comics, I was in college. I was sitting in class. I was just doodling stuff I was thinking about. I had one job where I worked at a front desk overnight, and I had one of those spinning chairs. And people no one would come through from like 2 a.m. to 4 a.m. And so I was just sort of sitting there. And one of the things I would do is I would just start myself spinning in the chair and see how long I spun. And I had been learning about angular momentum, and so I was thinking, wait a minute, that if I'm spinning, isn't it imperceptibly but still slightly slowing down the spin of the Earth? And I drew a comic about that, and it was really exciting to see that I was not the only person who thought about that kind of thing. A lot of people would write to me or send messages or something and be like, "Oh wow, I didn't know that there's someone else out there who thinks about like optimizing your path when walking across grid at on your college campus, or spinning in chairs to try to alter the spin of the Earth." And for me, it was like that, but even more profound, because I was learning there were a lot of people out there who were interested in that kind of stuff too. And I thought that was really exciting. It's been really amazing to get to find out that the stuff that you're sitting around and thinking about and interested in, that you think this can't possibly be going on in anyone else's head, right? To find out that it often is.
Yeah, it's a really great way of finding connection in this crazy mixed up world we have. And I mean, you've been doing this for a while now. I won't say exactly how long because, we're roughly the same age and that's becoming more apparent every day. But how have you seen your ability to reach people shift over the years?
I don't know. I think I've always just kind of assumed that if I take the things that I am interested in and the things that I'm excited about, and do my best to like express those, write about those, talk about those, if there are people out there who feel the same way, it will reach them. And if people are like, "Oh, I'm not really into this," that's fine too. It feels really presumptuous to write anything for general audience, because you're like, other people might not know about this specific thing, but also they have a bunch of stuff they know about and that they're working on. And, why would I assume that they would be interested in this thing of mine? So I always feel almost apologetic whenever I post anything. But I found that when I started off, I read a lot of comics, and so I was thinking, I read things like Calvin and Hobbes and The Far Side and, Foxtrot and all those growing up. Those were big influences on me. And one thing that was really exciting to discover as I was doing XKCD was sometimes I would, instead of doing a comic, panels with a punchline, I would say, you know what, I've been spending a while trying to map out all the IP blocks on the internet, or, the gravity wells in the solar system. What if I just like post this chart? And would post things that I don't think I knew the word infographic, but these data visualization charts, and they weren't really comics, but people didn't seem to mind. And I found I really liked doing that. And it sort of led me into doing things like uh, my book Thing Explainer and my What If question and answer blog and books, because it was like, oh, it's just fun to kind of use this medium to explain stuff and to illustrate stuff.
Yeah, and I mean the early version of the comic, if you go way, way back to the very first few, they seem like they were largely brain dumps, like whatever was going on in your head, which sounds like it tracks with doodling in college. And that approach, though, it's not quite the best for when you're writing a full length book. So when you're writing these books, how much of the work that goes into those is for fun, just like, oh, this seems like a fun thing to talk about, versus how much do you usually deliberately try to convey? Like, how much specific information are you trying to put in here versus, hey, this sounds cool?
Well, I've done comics occasionally about this phenomenon of how, like, for someone, with a certain kind of personality or, a certain approach to these things, it's really easy to trap us by, like, giving us a riddle that seems like it's solvable, but we're not totally sure how to solve, but we think we can solve it. Um, and people can derail me for like an entire day just by sending me like an interesting puzzle or a question that they want to answer, because I'll just immediately go off, diving down rabbit hole after rabbit hole of research to try to answer this question. And so part of what I tried to do with What If was harness that in some way, where it's like, well, wait, if I'm going to be spending 8 hours when I should be doing something more productive, researching to answer this person's question about Superman physics or lava or, rocket design, I might as well like take all the stuff I learned and write it up and share it with more people than just the person who asked me. And so what I do is not so much think like, what do people need to know? Instead, what I do is I want to get to an answer. Like, that's the thing that always really pushes me. Like, it is, someone asks me a question and I'm not like excited about doing research necessarily. Like, it's not like the idea of doing math is fun, but I'm excited to find out the answer. And so, I'll deploy whatever tools I can, which will be like research, math, science, et cetera, to try to figure out what that answer is. And then once I've got it, I usually find that there were like 20 approaches that didn't work out, and also some interesting stuff I learned that didn't have to do with the answer, but it was interesting anyway. And so at the end of that whole process, I think, okay, what is the most interesting piece of this? Like, what are the most interesting things that I have learned along the way? And how can I show people the answer that I got? Because that's what, got us started on all of this. And also the parts of the research that were useful to figure it out, or that were just too cool not to mention.
I got it. So there is a winnowing down process, so it's not an entire brain dump, but it really is that core of curiosity, is what it sounds like. That just kind of undergirds everything you do. So to kind of make it a slightly more formal sense here, rather than just, wow, this is cool and fun and we love learning things. What are your thoughts about it's sort of a still nascent field of science communication? And obviously your comic is more than just science, but you do a lot of science communication. But how do you think people making a deliberate attempt to communicate science to a broad audience, how can that help us navigate kind of the chaos of modern times?
I don't know. I think I certainly grew up consuming, books and shows and, media that was, in retrospect, science communication. Everything from, stuff like, I read the books by Stephen Hawking, Carl Sagan, et cetera. The TV show MathNet on PBS is Square One TV, which had a little segment called MathNet. I revisited recently. It was an educational sort of variety show about math. And watching it, I recognized, oh, wow, I see a lot of my later career in this show. And I did not realize how much this was influencing me. Um, And those kinds of things, I don't really know why they do them. Like I don't know what the goal is in educating people. I don't know exactly whether they were trying to accomplish exactly what they did. Um, but they were sharing stuff that I found really interesting and exciting and useful, and that shaped how I think about the world. And then when I go out, I'm not really thinking like, all right, I need to educate people on this because it's important for them to know this, because that feels kind of presumptuous, I guess. There are things where that's certainly the case, but I always sort of go into it with the attitude that I'm trying to share what I'm excited about and show people why I think something is interesting or important, and like inviting them to go along with me. Um, I don't know how much it's different from kind of any kind of teaching or communication. Like it has, it's a huge field. This whole area of communicating about science, but I don't know that it's necessarily that different from communicating about any other sort of specialized field where there are people who are very involved in it and they want to make it accessible to a wider audience. They say, we've discovered some important things here. We'd like to share them with you. If you want to share stuff with people outside of your field, you have to present it differently. And I think that's something that is hard to do. It's always hard to put yourself in the shoes of people who don't know all of the things you know. That's something that's really, really struck me with writing about science. Is it's hard to remember what it's like not to know something, and so it can be really challenging to try to think like, how did it feel before I understood this, so you can figure out how to express it in a way that people will understand. And that's something that I struggle with. And I think it's hard to do maybe without condescending to people. That's something that it's sort of, I see people talk about struggling with. Like you need to simplify things without talking down to people, and that's a challenge. And I always just try to think about, what did I feel like before I understood this, and what was it that made it click for me, and what drew me into it in the first place. And then I just try to like think about like, how would I share that with my past self, and figure that maybe that'll also work for people who are in the place I was in before I started looking into this whatever random topic it is.
I think that's relevant advice, and I think that is something that has been neglected in the sciences. And it is the same. It's not like you're communicating something in an alien language. Like, you're communicating ideas and principles that affect all of us. But scientists have been, I guess, just neglected that side of our training. It's not like every scientist has been required to take a communication class. I think we're moving that way, but we're not quite there yet. But do you have a few personal favorite examples, and they could be from your work or from stuff that you've seen out and about, just examples of science reaching the public and changing lives in a good way?
Oh man, I don't know. That's that's a tricky one. I'm thinking about, there are some cases of people kind of identifying a problem and then bringing it to the attention of the public, and then the public, the policymakers and stuff, like reacting to it and doing something about it. We had people. There's the example of like the ozone hole, where we figured out that these compounds were breaking down the ozone layer, and then past and this circulated around. People said, "Oh, that looks bad." You can see the big picture of the color map of the ozone thickness, and there's a giant hole over the southern part of the globe, and it's very vivid. It like seems bad. It is bad, and it's kind of easily digestible because you have that picture. And then we, in the '90s, passed the Montreal Protocol. We really banned a lot of those compounds, and have made a lot of headway on that. Um, and that's sort of what the hope, when you have something where you want to affect policy in some way where there's a problem and there's something that it's important for people to learn about. But I also think that I really feel like my life personally was changed just by people like learning about the things that we don't understand. Like learning that there are all these mysteries out there that we have not figured out answers to. When I was a kid, I found books on physics, and I read things like, I mentioned there's Carl Sagan. I read a lot of those sort of pop science books that would talk about the problems of string theory and quantum mechanics and unifying relativity with quantum physics and figuring out the ultimate theory of everything. And I thought that was so fascinating. It's like, oh, there's this thing we don't understand, and someone needs to go figure it out. And one thing that I really wish I had sort of learned earlier was how many really simple problems are also unsolved. I was really delighted when I learned how much we don't know about very basic processes. Like it was only in the last decade or so that we really got a handle on why ice is slippery.
Right.
I found a paper on that where it's like there's a common explanation you always hear. That explanation is wrong, but we weren't sure what the right one was. There are similar things like we don't know how lightning gets started in clouds, partly because it's hard to go up there and check them. We don't have good models for how sand flows. There are all these like very simple practical problems where lots of people have worked on them, but it's just very hard. And sometimes science is presented as like, well, we've figured out all this stuff, and there are now these big, deep, fundamental questions, and you have to go work at a particle accelerator to tackle those. And it was really exciting for me to learn that there are problems like in kind of everyday physics where we don't know the answer, and in other fields too. Like I'm sure you've run across a lot of these where it's like, what's going on in this mountain? No one has climbed up there to look, so we don't know.
Yeah. Yeah. I mean, the big one in volcanology is that we can't predict eruptions. And so everyone is, oh, when is it going to erupt? I don't know. I mean, we can look at clues and available evidence and tell you when it's likely, but we can't say, oh, yeah, next Tuesday at 7. Like, I wish we could. But yeah, those are the exact mysteries that I think drive a lot of scientific curiosity. And I think it's important to not lose sight of the forest for the trees, because we're all trying to go to particle accelerators when we still have these very basic things. And I mean, a discovery that happened when I was a working geologist, pretty much right out of grad school, and I saw it be figured out in real time, was why do the rocks at Racetrack Playa in Death Valley move? And when I started studying geology, they didn't know. And then they figured it out. So it's like, these things are happening in our lifetime, and that gets me excited.
So wait, so why are the rocks moving?
So it's because there is a cycle of freezing and melting that goes on in the playa, and it's very shallow. The water table is really high there, and so basically, when the water freezes and the ice is present, the rocks actually slide along the surface, and then when it melts, the rocks stop. So that's why they have those big long tracks after them. And
And so
they
this all
didn't.
comes back to the mystery of why ice is slippery.
It's ice, man. Everything's ice. So because like, okay, you got me all excited, and I'm like, all right, let's talk about what's exciting. So your work is super eclectic. I mean, I love that you reference iambic pentameter and, MC Escher, and then also particle physics in what you do. Your interests are pretty darn varied. So what are a few things that have you really excited for the future right now? I mean, on any kind of future. It doesn't have to be science future, but if it's science, bonus points.
Man, I don't know. I've always, for a long time, I've been really excited about every time there are new discoveries with exoplanets. Like when I was a little kid, we didn't have solid confirmation of any of these, and now there are thousands and thousands of them. And every time we launch a new instrument and get a new glimpse of like, this is what's going on in the atmosphere of this planet. This is a new type of planet we didn't know existed. I find that stuff really exciting. But and I don't mean to pander here, but I just find myself thinking about geology a lot. Like I didn't do
Woo!
any of that in school. I I didn't take any geology classes in school, but I've been walking around on tectonic plates for my entire life,
I
and
hope.
I just find it really kind of mind bending to think about the spans of time involved. Like where I live up in the Northeast, I'm on rocks that originally formed from I think a volcanic arc in the southern hemisphere, like near Antarctica, and that migrated north, and that was like 450, 550, 600 million years ago, that migrated north, collided with North America, got sort of sutured on 400 million years ago, um, and then they've just been sitting here. And it's just so weird to me that I can walk outside and look down at this rock, and it's been there for a span of time that is like impossible to wrap your head around. And the fact that we've got this whole other, we move around, we walk around on the surface, we pick up objects, we run water, we do all this fun stuff manipulating the world around us, and then like underneath there's a similar process happening, but just on a time scale that's like a million times slower. um I don't know, it's like it's hard for me to think about things sometimes. It's the way people talk about like looking into the abyss or like staring up at the stars being a kind of terrifying experience because you realize how small you are. I feel that way just like looking at rocks. And so anytime I run into someone who knows about geology, I always end up like, I just want to ask them questions about like what parts of the earth they study and what they like, when things happened and what happened there. And um it's just like there's an entire other story happening,
Yeah.
right under our feet.
That's I appreciate the pandering. I will take that any day of the week. And I will tell you the thing that broke my brain. I mean, geology broke my brain from day one because it is so, it's like, wait, you can explain mountains? Like, whoa. That was like giant revelation. But it was when I first set foot at the summit of Mauna Loa volcano, world's largest,
Mm-hmm.
as you know. In the summit there at the time, when I first walked on those lavas, I was older than they were. And I was like, wait, this is a chunk of a mountain, and not just any mountain, like the world's biggest volcano. And I am older than what I'm standing on, this part of it. And I was just like, what? So, I mean, the earth is constantly creating and destroying itself. And I love that. It seems so much bigger than all of us. So we are speaking the same language here. And I do want to talk about lava because I have to. And you mentioned you wanted to talk about lava. So this relates to your work. For the people watching this on YouTube, I have the copy of How To right here. This is wrong side. How To, one of Randy's awesome books, and there is a chapter called How to Make a Lava Moat. And in How to Make a Lava Moat, I'm very grateful that you, or How to Build a Lava Moat. Let's get it right. And so I'm very grateful that you took the time to discourage people from actually building home lava moats because you pointed out the cost is prohibitive unless you're Elon Musk, but let's not give him any ideas. Um, but I did want to ask you how you determined, and you put it in this book, how did you determine that a serving size of lava is 1 kilogram?
Well, so I wanted to discourage people from eating lava, um, and and I was thinking like, okay, lava's not very nutritious, and somehow that just led me to think like, well, wait a minute, do I know that for sure? I'm pretty sure you shouldn't eat lava, but and then I thought if you made a nutrition label for lava, what would it look like? Because the nutrition label, I think that was sort of the moment I realized, like, wait, you could put one of those on anything. It doesn't have to be food. Like, they wouldn't put them on things that aren't food, but it's just a list of what's in it. I can look up what's in lava, and so I like found some papers on like lava doesn't have any carbohydrates, or it like doesn't have a lot of protein in there, but it does have potassium. There's magnesium. There's a bunch of these different elements. There's iron.
Lots of
And
iron.
so I tried to figure out if you took an amount of lava, what how much would it meet the RDA for each of these nutrients. this was one of my favorite things about doing a book where we actually got a fact checker who's we had a couple of people who were, and it's fun finding people to fact check this kind of thing, because you really have to have like a specific attitude toward the world to take a question like this and like, where do you even start in figuring out if that's right? And I remember that I got notes from the fact checker on that chapter where it was like, and so I found a couple of people who are good at solving this kind of problem the way that I am. That was my favorite fact checking note on the lava chapter, was like, this all looks good except that magnesium number seems high. I've none of the lavas I found had that much magnesium. And I was like, oh, maybe I initially found some like really magnesium rich lava, but when I went back, I'm like, you know what, you're right, that's too much magnesium. So I fixed it. You know, that the version in the book should be about right. So if you are going to put together a lava meal, that should be good for sort of an average typical lava, but it varies so much. Like, I just tried to find like, what are the most studied lavas. I know.
Yeah.
So you've talked about, you have not tasted lava.
I mean, I
You've
could right now. I literally have a piece of lava right here because
okay.
of course I do. But it is, you wouldn't, I've licked plenty of lava when it's cool, but I mean, I guess I've eaten some too, because when you get and you're working in an area and this stuff breaks, I mean, this piece is really, it's a frothy, I'll show it to Randy and to our camera.
Mm-hmm.
It's very vesicular. It's got a lot of air in it. So when that stuff breaks down, which it does pretty readily, and it blows around, oh, I've definitely swallowed a bunch of it, but not intentionally.
So you mentioned, when we were talking about lava the first time, you mentioned how it smells.
Yep.
And does it vary? Like, are there lavas that are like stinkier?
Yeah. Oh, yeah, for sure.
Can you
It depends.
tell? Can you tell things
It's
about it?
Yeah, it depends on the sulfur content. If
Okay.
it's a really sulfur rich area, you know, if the magma chamber has a lot of sulfur, if you see a lot of fumaroles, the basically the areas where the degassing occurs, which are usually marked by a lot of sulfur crystals, you know, it's going to smell really strongly of rotten eggs. If there isn't very much sulfur, it's a much more neutral smell. Then you usually just smell burning if there's any vegetation around. So it's not directly the lava that is smelling at that point.
That makes sense. It's
Yeah.
just seasoning on top of it,
Yeah,
a little
and you know
biological
what?
seasoning.
Everyone thinks it must be disgusting. They're like, "Oh, how could you do that? I can't stand the rotten egg smell." And I'm like, "But it's not like sewer gas smell. It's a little different. Native sulfur is a little different, and I don't mind it. I mean, yeah, it stings your eyes, and the other acid gases don't do wonders for your respiratory tract, but it's like it's so cool."
You know, chemists always this is one of my little favorite things. Chemists always talk about sulfur, and to tell you what it smells like, they're like, like rotten eggs. And I think this is something that's changed some over time, because do chemists all just have like eggs rotting in their houses? I don't actually smell rotten eggs. I'm not sure I've ever like broken an egg and had it be rotten.
Rotten. Yeah,
I
maybe
think
it's
it
an old
used to
time
happen
thing.
more.
Yeah, and now we have refrigerators that
Yeah.
presumably eat our eggs in a reasonable amount of time.
Yeah, and I think that that's changed, but I also really like the idea that chemists just like don't know about refrigeration, and all their houses are just full of rotting eggs all the time. So they're like, that omnipresent rotten egg smell that we all have in our houses.
I'm thinking maybe they're all just urban chicken farmers, and they've all
Aha.
gotten to the urban chicken keeping lifestyle, and therefore they have more eggs than they know what to do with, and their friends are sick of getting them as gifts, so they have rotten eggs. That could be. I don't know. We should look into that. Our
So
chemists, urban chicken farmers.
so when I was planning out a lava moat, not to I was curious if I could ask you.
Yeah.
Um, I tried to figure out how wide you need to make a lava moat for it to be effective. Because like at first I was thinking, I mean, any amount of lava, like you probably can't even get near that. And then I tried to do the calculations, like how much, if you tried to like jump over a 1 meter wide strip of lava, like how badly you'd get burned. And it looked like you might not, like that might not be enough to prevent someone from breaching your threshold. Like, could you jump across a lava stream if it was like narrow enough?
Yes, we do not advise that. Like, everyone listening, do not do this. You didn't get it from me. If you
Of
did,
course.
you got it from Randy, not me.
Hey,
But
no, no, no. I'm trying to keep people
no,
out. I'll have signs around my lava moat that are like,
okay.
"Do not jump across this."
Yeah, well, no, you could totally do it. It is extremely hot. I have poked a river of lava with a stick, and the stick caught on fire, of course. And I have also lost my favorite pocket knife into a river of lava, and I did not reach in after it. I wanted to, but the radiant heat was like, oh, nope, never mind, that's gone.
Did it sink?
um, it was subsumed because the lava was flowing, and it pierced the crust because the crust hadn't solidified yet, and so it was just sort of slowly overtaken.
Okay.
It's like watching one of those, those little the snakes you get for 4th of July, that
Mm-hmm.
you light them on fire and then they carbonize and they curl around. It kind of looked like that was eating my knife.
Huh. Okay.
Yeah, it
Yeah,
was
that's because
very weird, very weird.
yeah, because like I always imagined. I mean, I always figured that lava would be a much more common thing to encounter, like quicksand, when I was a kid, because it shows up in media all the time. Um, and like quicksand, you'd see, in cartoons or whatever, things falling into it and sinking. But both lava and quicksand are like significantly denser than people. And so
Yes.
like I'm curious like what stuff actually can sink in lava if it's, molten enough.
I mean, if you throw yourself into a lava lake, which is my preferred method of death, by the way, if anyone's listening, just because you're guaranteed to die, like you're not going to survive. That's it. You're done. The gases will
I
get
don't
you. The fall
I
will
don't know
get
if that's
you.
my only criteria for preferred method of death.
Well, it's also dramatic and kind of cool, and
That's
you'll get a news mention at least. But if you do that, like let's say a person flings themselves into a lava lake, I mean, they're going to hit a solid at first. I mean, because lava is well, it's a plastic solid, so essentially you're hitting something solid. It's going to hurt, but it's going to start melting and basically taking you into it pretty quickly. So it's not a sinking like if you would imagine throwing a bowling ball into a pond. It's not like that at all, which I think is what people do imagine. So don't think that you will. It's not Terminator either. So yeah, there's all
although
these misconceptions, but that would be really
yeah.
cool. The Terminator, like thumbs up, dying kind of thing.
I was I once made that comparison of like throwing a bowling ball into a pond, and then I was surprised to learn the average bowling ball at a bowling alley is less dense than water. And
What?
so
Oh my god.
if you dropped a bowl, because someone asked me about this, they were like, if you dropped a bowling ball over the Marianas Trench, how long would it take to sink to the bottom? And I found that like the serious bowlers will use heavier bowling balls and those tend to be um, a little bit more dense than water, so they will sink. But the average, and I was trying to think like, but a normal bowling ball that's like not from some super competitive, if you go Google and look at forums, people are all talking about really heavy bowling balls because these are all like enthusiasts. But I found I like browsed Flickr photos of random bowling alleys and like counted how many of each weight they had on the rack to just try to get an idea of like a regular bowling ball. And a regular bowling ball is less dense than water.
That is so shocking, actually. But now I'm gonna next time I go to a bowling alley, I'm gonna like heft the bowling ball and be like, water is denser than you.
Yeah, I mean water's heavy. It's
It
weird.
is. It is. It's surprisingly heavy. Okay. I do have a couple more questions that
All
I should
right.
ask you to try to make this still an actual podcast and not just Jess and Randy talk about random stuff, which could be a great show in and of itself. But okay, so I want to know what's coming over the horizon for you. So, is there anything that you can kind of tease for your fans out here in the scientific world?
I'm always sort of working on stuff and waiting to see which thing, is exciting enough or interesting enough or like complete enough for me to release it. Um, I do have coming up later this year. It is the 10th anniversary of my first What If book. And so I'm releasing a version of it where I've gone through and annotated it and updated it with like margin notes showing like new stuff that has been learned since I wrote this, or occasionally like someone who has gone out and tested my idea in some way and like got results, and they've shared them with me, and I can like talk about like, here's what happened when someone tried this. For at least a few of them where that's possible. We had one questioner who then went on to a music career, and I went to some of her concerts. It was cool. I include a bunch of details like that, and I also, because it's the 10th anniversary, I just tried taking a whole bunch of the quantities in the book and multiplying them by 10, and then seeing like in the margins, like, here's what would happen if you ate 10 kilograms of lava instead of one, or like, here's what would happen if this were moving 10 times faster. And often the answer is just like similar destruction, except much more so, and I get to, but occasionally it's like quantitatively or qualitatively different.
Mm.
And so I had fun doing all of that. And so that'll come out at the end of the year.
Oh, that's cool. Well, we don't have long to wait because we are close to the end of the year. So I'll be
Mm-hmm.
looking forward to that. So then I have a last question that's actually a two-parter for my guests here on This Is Science. The first part goes like this. Okay. We are the Union of Concerned Scientists. Randall Munroe, why are you concerned?
Ooh. Um, I don't. I mean, just the general unimaginable scope of time and space that does not fit into my brain. Uh, I feel like there's a general existential concern about the world. I I think I'm concerned about just a lot of the normal the things that any one scientist or not is concerned about. I think uh, as scientists, there's sort of the obligation and to talk about and focus on climate change. It really is like the reason the Union of Concerned Scientists does so much, communication about it, and the reason so many people talk about it is that it really is a thing that we're doing that we should do differently, and it's hard to kind of get across and illustrate why that is and what we need to do about it, but it's important. And so I do spend a lot of time worrying about that, just like opening up the daily CO2 readings from Mauna Loa, the looking at like the rate of adoption of solar. I I feel concern about that, and also I really appreciate people um, who combine that concern with like not being too pessimistic or too like fatalistic about it, because I don't think that's helpful. I'm a big fan of Katharine Hayhoe. She's the writer and scientist who works on the IPCC report and the climate assessment, and she's talked a lot about seeing climate change as a problem, but a thing that we will make progress on and are making progress on, and we just need to appreciate what things are working and what aren't, and do more of those. And she, I think, is she does a lot of very deep thinking about like how to talk to people from different parts of the country and the world about this problem. And I'm a big fan of her. So
Likewise, likewise. She's
yeah.
great. So there is, we have to end optimistically because I share the core of optimism that comes through in a lot of your work. But what are you doing about your concern?
Gosh, I don't know. I think I've tried to not like, one of the things that makes talking about politics difficult is that it really encourages a kind of like lecturing people, which is like an impulse that I have the same as anyone. I drew a comic about uh, early on about the compulsion to engage on the internet because there is someone who is wrong and you have to tell them they're wrong and yell at them. And I think that that's like often not very helpful, and people don't like being lectured to and condescended to. And so one thing I've really tried to do is figure out how to just show people what I am concerned about. And I did a chart at one point showing that just the temperature history of the Earth over a long time scale. So you have to scroll and watch like the climate on the Earth has changed in the past, and it used to be really cold in the ice ages, and in the last glaciation, and now it's warmer. And so I made it so you scroll and you watch that change happen, and that change happens over thousands of years. And you can see the line sort of weave back and forth as you scroll, and like the temperature climbs up to where it is now, and at the very end you see how quickly the current temperature change happens compared to that, and it's just like suddenly a sharp bend off to the side. And and I shared that just because like I felt like I hadn't seen it illustrated like that. And I didn't I don't want to yell at people and be like, you should be concerned about this. Instead, I tried to just show it. And I had a lot of people who wrote to me after, and they're like, wait, is this true? Like this seems really bad. And I was like, yeah, it does seem very bad. But I tried, so I try to show people things that make me concerned and then let them decide how they feel about them, instead of sort of yelling at them and telling them you should feel this way, because all that does is make them feel like, well, if they don't feel that way, there's something wrong with them, or they just don't like being yelled at, which like who does? And so I think that's what I try to do, is I just try to like show people what it is that I am thinking about and concerned about and why, and then just have faith that other people will feel the same way as me if they see the same things that I do.
Well, that's a great answer. And thank you so much for all of the work you're doing, the fun and the actually necessary parts of it. They are a delight to take in and to share. And I know I speak for my colleagues here at UCS when we say thank you for doing what you do. We love it. And I really appreciate your time.
Oh, well, thank you so much. It was so wonderful talking to you.